This is the final boat trip project by Marsalis Horton, Noah Hislop, Chris Jampier, Luke Davis, and Dagi Zoxy. So what is this project about? This project is about the corrosion of materials on naval vessels, and it is also about how the corrosion of materials on vessels over water can be highly detrimental. And this is also about corrosion and its relation to chemistry. So when we look at corrosion on vehicles in the water and above the water, it can be highly detrimental because the corrosion can tear apart the parts of the boat or vessel, and it can also damage the insides if there's enough corrosion.
My name is Marcellus Horton, and there are five group members in our team. The people in our group are Noah Hyslop, Chris Tampier, Luke Davis, Desi Zashi, and their individual roles within the group were the team manager, which is Daji, the team facilitator, which is Luke, the product managers, myself and Noah, and the resource facilitators, which is Chris. The problems we had uh, within our group was that our group was uncoordinated and we couldn't meet up to do the assignments, our group assignments. We solved this by downloading a common media app, Instagram, to coordinate doing our assignments. Our agreement helped us find our way by helping us coordinate as a team and being able to move forward as a group. We had five theses, and the first one was about materials being resistant to high pressures of the deep ocean. The second one was materials being resistant to corrosion from salt water, like in water vessels. The third one was to prevent the influence of unpredictable airflow and low altitude of the ocean. The fourth being prevention and detection of damage to machinery over time. And the fifth being fuel efficiency at sea, along with refueling methods. The reason we chose the second one is because it was the most applicable to the prompt.
The Selma ship wrecked years ago, and there were no methods to repair it at that time, so it's a shipwreck now. And the Causeway Bridge is just a bridge for trains to pass and ships to go through. The Pelican Iron Cut is a shortcut for ships. The USS Texas battleship is not in use anymore. The oil rig is used to drill oil from the sea, and it's connected to the Galveston Island. The Selma shipwreck rates are proposal the most because um, it corroded years ago because there were no methods to protect it from corrosion at that time, and there were harsh environmental conditions, so it wrecked.
Alrighty. I'm Noah Hislop, and the resources we use, they helped provide they helped provide information on our thesis. And what we found was there were various types of corrosion, along with two ways of preventing it, which were using titanium and amino modified epoxy coatings. So the types of corrosion are, it starts with general corrosion, which is the most common type, and it's a uniform attack across the surface of a metal. And since it's a uniform attack, it makes it much easier to predict and prevent. The pitting, so the other types, which are pitting, crevice, and intergranular, are all types of localized corrosion, which is just a more concentrated version of the general corrosion. So pitting is small holes that are corroded in small sections of the iron. And they're normally caused by chloride ions. Crevice corrosion occurs in confined spaces under seals and fasteners, such as like screwed in bolts, kind of like the one in the general corrosion image. Intergranular occurs in between the grains of the metal, which can be seen by the microscopic or the more microscopic image. And it comes from impurities in the metal and along with improper heat treatment. The last is called galvanic corrosion, which is caused by two metals being in electrical contact with each other with a electrolyte as a conductor, I guess. And it can be prevented using like a more reactive metal such as zinc as a sacrifice. So the two methods that we came across was using titanium and amino-oxidized epoxy coatings. Titanium occurs in a naturally metallic state, which makes it less reactive and less corrosive. An amino-oxidized epoxy coating is just a coating over the metal that is currently used or that is normally used in aircraft.
So nowadays, the corrosion has become a very big topic. The government have to spend the money on the corrosions, like higher than actually the military spends. And so for the scientists, like they have to really consider about how the corrosions has become the like super big topic in the nowadays. So actually the corrosion has covered in a lot of areas such as electronic chemistry, material science, and microbiology, and even in the industrials like aerospace and the boat making. And actually, the corrosion has caused like very serious damage to the marines because the boats have going to be the corrosion, and all the corrosion has going to be heavily damaged the entire sea environment. So for the engineering, they have to seriously to figure out a way to prevent all those corrosion happenings, to find out the new materials that's going to be greatly going to be environmental friendly and also going to be strongly to prevent the corrosions as well, and maybe to consider in the other parts, such as very lightweight and also be easier to transport stuff. And so our idea is going to be use the titanium to become like a main stuff to as its properties to help to prevent the corrosions, since titanium is very light and also have the very good prevented in the corrosions. So this is our resources come from. All the references come from NASA's corrosion PDF and also even from our Texas A&M experiment.